Welcome back. Today is day 6 of our Solving Quadratics unit. Today we will be solving some fun area problems. Just a reminder, a copy of the handout is provided in the description so you can follow along. Enjoy. Alright, let's solve these problems. I love these problems. A rectangle pool with dimensions 20 by 40 feet is surrounded by a walkway with a uniform width. So, well, we know we have a pool right here, so let me just write this in. So we have a pool here. Here's the pool. Alright, and then the rest of it's going to be the walkway. Alright, but now the key word that they're using here that we need to pay attention to is the uniform. So what do they mean when they say it has a uniform width? Well, I like how they drew these in here. They drew this piece and this piece. So that means that those are going to have the same width. So whatever, they're going to be the same all the way across. All right, so it makes it look nice. You know, you don't want to have one side longer than the other because then it won't look nice. All right, so got that part. Let me write that. If the area of the walkway is 500 square feet, find the width of the walkway. All right, so what we're trying to do in this problem is to find the width of this little walkway. Now, there's a couple ways you can do this, but the first way I look at this, and I'm looking at this, I'm like, you know what, I should probably break this into little pieces. So I'm going to write this down. So the first thing we know that the area of the walkway equals 504 feet squared. Okay, so that's what we know. So that's the only thing we know so far in this problem. Well, we also know that the length of the pool is 20 feet, the width of the pool is 20 feet, and the length is 40 feet. All right, but besides that, we don't know too much else. What could we do here? Well, the first thing I see is, you know, when I think of area, I think of just the space that it covers, and I think of like cutting this into little pieces. So I'm cutting this piece and this piece over here. I'm cutting this over here, and I'm creating a whole bunch of like either squares or rectangles. Do you guys see that? So when I cut it straight across here, when I cut it straight across there, how long is that side? Well, if I use the part that it has to be the same uniform, so this is X, that means this would have to be X. And the same thing here, if I cut this into a little piece over here on this dotted side, this is X also, and this would have to be X also. Same thing over here, and X and X. Same thing here. This one's already kind of written for you. This is X, and this one's X. All right, perfect. Now I have basically like 1, 2, 3, 4, 5, 6, 7, 8. I've cut the walkway into 8 pieces. So if you take a look here, so I have this piece over here, and this piece here, and this piece here, and these are all the same. And what do we know about those pieces? What's the area of those pieces? Well, you have one side length X, the other side length X. So that means the area of those pieces, I'm going to write this down as 4 times, oops, rewind that, 4x squared. Does that make sense? Because x times x is x squared. So if I was to write this in, this piece right here would be, let's write a different color, this piece right here would be x squared. That's the area of that little corner. And I'm going to have 4 of those exactly the same. Now, the next piece, if you take a look at this, you notice you have 2 pieces here the same. So this piece, this green piece, and this other green piece. Now, what would the area of those pieces be? Well, we know the pool length is 40 feet, so the width is x, so this would be, we're going to have 2 pieces at 40x, just doing the length times width, back from like 3rd grade. All right, and the last little part, we have this little section over here. We have this section right here, and this section right here. So that gives me I'm going to get 2 pieces, or 2 areas that have, that's 20 by x, so that's going to be 20x. And what do we know? We know that that has to equal, that must be the same as 504. So does that make sense? You have the four corners, which are the pink pieces. You have the two middle pieces, the green ones, the top and the bottom there. And then you have the two side pieces, the blue ones there. And what do we know is that that total area has to be 504 feet squared. All right, now let's see. Let me simplify this a little bit and let's see if this starts looking like a math problem that we can do. So what do I get here? 4x squared is just 4x squared plus, that's 80x, plus another 40x has to equal 504 square feet. Let me simplify this one more time. So I'm left with 4x squared plus 120x is equal to 504. Okay, perfect. Now, all of a sudden, I'm looking at this and I'm thinking, this looks like a quadratic. And I know how to solve problems like this. This actually looks like a problem that I probably can complete the square with. Let me simplify this real quick. Remember, we can't have, this 4 is bothering me. I can't complete the square with a 4 there, so I'm going to divide all my values by 4. And what are we left with? We're left with x squared plus 30x, and what's 504 divided by 4? I believe it's 126. And now guess what? We turn this crazy big problem into a nice little quadratic where we can complete the square. All right, let's go ahead and do this real quick. So we'll take our b value divided by 2. I'm going to write it here on the side. So take b divided by 2 and square it. And what does that give me? 30 divided by 2 is 15, and 15 squared is 225. So I'm going to add 225 to both sides of my equation. And now we can factor this real quick and simple. We can finish this problem up. So this should factor out to be x plus, I'm going to skip a step just because I'm running out of room, x plus 15 quantity squared is equal to, what's the sum of 126 and 225? That gives me 351. Okay, next step. Now completing square, this is just a simple algorithm over and over, same thing. So we're going to get x plus 15 is equal to plus or minus square root of 351. And we're almost done here. Having little mistakes here. There we go, finally. Subtract 15 both sides. I'm going to skip this step actually. That should be pretty simple by now. So we'll get x is equal to negative 15 plus or minus the square root of 351. Perfect. And what does that evaluate to? So I should get two answers. Remember, when we're solving this, we should have two answers here. So x is approximately, and if you need help with our calculator, you can always go to Desmos. It has a nice little calculator. You just type this in and you'll get your answer. So I'm going to go with 3.73. And my other answer is approximately negative 33.7. I don't know why I rounded that to the nearest. 73. Perfect. Okay. So there are my two answers. Now, let's check back to what was this problem talking about. We're talking about what was the width of my walkway here. Well, obviously, when we look at this, it doesn't make sense to have a walkway that has a negative width. So let's just cross that out. That's not going to make sense. All right, so that means my answer for this problem should be x is equal to 3.73, or 3 73/100ths. Now, if you are actually doing some construction here, to construct a walkway, that accurate is not going to be that easy. So I'm going to round that up, and let me just check this answer. Let me just check to make sure this is working properly. So remember what we said earlier. We said the area of the walkway, we said that was going to be 4x squared. 4x squared, let me write that. 4x squared plus the 80x plus the 40x. Now that would give you the area of the walkway. And again, we simplified that a little bit, and we had 4x squared plus 120x. Now, we just said that the answer for this problem, the walkway, needs to be basically 3 foot by 3 3/4 feet. So I'm going to check that as an answer because I want to check to see what that gives me when I solve this problem. So again, usually when I solve these word problems, I'm always going to check my answer to see, did that make sense? Does my answer make sense to me? So 3.75, and I'm going to round it because in real life, I used to do a little bit of construction. I build stuff, so going that accurate is not going to work. But 3 3/4 foot, we can do that. And let's check our answer. Let's plug that in decimals and see what we get. And I get an answer of 506.20 feet squared. And that's pretty close. Now, remember I rounded my answers here. We got an answer when we calculated it 3.73, and I'm rounding it to 3.75, and that's what I'm checking. All right, so again, that's one way to do this problem. Again, using completing the square and just kind of going piece by piece, like, and we're trying to write an equation for it. Now I'm going to show you a second way of doing this problem. Now this one's going to set up a little different, but you'll see after a while the calculations will be the same. So I'm not going to go through the calculations again, but I'm going to just show you a different way of looking at this problem. So again, a lot of people see the same little section here. And I'm going to cut those little 4 corners so you can see those. All right, now, but what if you saw this problem a little bit different? What if you saw this as, like, as soon as I see these little pieces here, I think of like the area of the whole thing. So the whole, subtract the area of the pool would have to give me the area of the walkway. Does that make sense? So if I took the area of the whole thing, which is the walkway and the pool, and I subtracted from that the area of the pool, I would be left with just the area of the walkway. And so some people see the problem this way, and this is how they would do it. Now let's see. What do I know about this side length here? So this little piece over here, this is x. Okay. And then this piece over here is 40, and this piece is x. So how long is the whole side? How long is that side length? Well, I can write that as 2x plus 40, and that would be that side length. Does that make sense? Because x plus x is 2x, and then the plus 40. Now, what about your other side lengths? What about your other piece here? Well, this is x also. That's x. That is an ugly x. Let me erase that and try that again. This is x. And you can see that your height here is 20, so that'll be 20, and this would be x also. So what's the length of that side? So the length of this side from here to here is going to be 2x plus 20. And that would give me this side length. So if I wanted to write an equation, what is the area of the whole thing, the walkway and the pool included? Well, the area would just be length times width, so that would just be 2x plus 40, and then times, what else? 2x plus 20. Okay, and then we're going to subtract. Now, what's the area of the pool? Well, the pool is just a simple rectangle, 20 by 40. So the area of this pool would be, what is that, 800? Yeah, the area of this pool would be 800. So I'm going to subtract the 800. Okay? And I'm left with, and in the problem, they told us the area of the walkway. The area of the walkway was 504. Perfect. All right, so does that make sense? So we've taken the area of the whole thing. That means the walkway and the pool. we're going to subtract the pool, which is 800, and then that will leave us with the area of the walkway, which we already know is 504. So let's do a little calculations. This is multiplying from a couple chapters ago. So let's multiply this out. 2 times 2x times 2x is 4x squared. And then 2x times 20 is going to be 40x. We have a 2 times 40, which is an 80x. And last, we are going to have 20 times 40, which is 800. And then we're going to subtract the 800 from the pool, and that should give us 504. Okay, so we set this problem up a little bit different, but what do you notice? I notice right now that this positive 800 and this negative 800 will simplify out, and so we are left with 4x squared plus 120x has to equal 504. And now this is the same equation that we solved in the previous problem. So again, we could complete the square and do the same work here. But again, I just wanted to show you that there's other ways to look at these problems and other ways to set these up so we can get answers. And again, I've only covered 2. You probably have another 2 or 3 different ways that you can do this problem. All right. I want you to try the next one on your own.
Here we go.